Hello and good afternoon. How is everyone? कैसे हो सभी? I hope everyone is good. So today in the class, what we will be doing majorly, so we will discuss questions based on current electricity. Last lecture also I discussed current, and we solved some good number of questions, but still we couldn't solve much. We only could solve some 7 problems done, and I gave homework. How many of you did the homework? How many of you did the homework? Chalo, let me know here in the Zoom or on YouTube. Let me know how many of you did the homework. How many of you went through the notes at least? No one did? You should participate whenever I'm asking anything. Otherwise, what happens now? I feel like I'm not getting heard. And in that case, time and again, I ask the same thing, and that kills our time. जैसे पिछले 2 मिनट से मैं पूछ रही हूँ, how many of you did the homework? How many of you went through the notes but no reply? So I'm bound or I'm forced, I can say, to ask it again and again. Yeah, reply to दिया करो, please. If it is possible, please do it. है ना? Anyway, that's one part of concern, but one thing I want to say is कि on weekend classes, whenever I'm discussing something or whenever I'm coming with some number of questions, my only target is to let you solve some questions so that you can also learn concepts at the same time, so that you can prepare yourself for upcoming exams, I must say. Done? So ऐसा नहीं है कि just for the routine I'm coming here giving you some 6 or 7 questions and then going away. No, I have a purpose, and I really want you people to be present in the class both physically and mentally. Okay, so your weekdays classes will also start very soon from Thursday, I guess, and you are having unit test, so prepare well for unit test as well. But for this 40 or 45 minutes in this class, please be attentive. ठीक है, क्या करना है? Attention देना है. इसलिए तो देखो, मैं तुम लोगों को शॉर्ट नोट्स के थ्रू भी ले जाती हूँ, so that I can explain a bit before giving you any question. Done? So now let's get started with the question. ठीक है? Sorry, not with the question. First, let me tell you what portions we will be covering today. So Kirchhoff's law first. Then we will see cells, that is batteries in series and parallel. And then we will see some shortcuts for the circuit. Done? So we will learn it bit by bit. So chalo, Kirchhoff's law you all must have studied. There are 2 laws in it. One is your Kirchhoff's current law and another is your Kirchhoff's voltage law. Okay? So what are these? First, let's go through this. जल्दी से recap करते हैं. So KCL states that if there is a junction in your circuit, if there is a junction, then whatever amount of current is coming to the junction, same amount of current will go out of the junction. So here there is one junction in the example that I have taken, and let's call this junction as O. So you can see here I1 current is coming to it, I3 current is coming to it. So total amount of current coming to the junction is how much? I1 plus I3. At the same time, total amount of current going out of the junction is how much? I2. So according to KCL, current coming to the junction will be equal to current going out of the junction. So you will write I1 plus I3 is equal to I. So this is your KCL. Now what is KVL? So KVL, Kirchhoff's voltage law, it states that if you're going to add voltage in a loop, then it will be equal to 0. Again, you can use KVL not for loop as well. and it has applications. Question come from that portion both in G and NET. So it's very easy. जैसे मैंने यहाँ पे example दिया in this circuit, if we have to write the KVL for this closed loop, suppose. So I am starting from A, and if I'm writing KVL for closed loop, means I will start moving from A and I will come back to A. Then only it will form a closed loop, right? So चलो लिखते हैं. कैसे लिखते हैं हम लोग? Voltages को लिखते कैसे? So we always give negative sign when we are moving from higher voltage to lower voltage. So if we are going from high voltage to low voltage, we will give what? We will give minus sign. And we will give plus sign if we are moving in the opposite sense, like from lower voltage to the higher voltage. जैसे अगर you are moving across a battery, across a cell. So अगर मैं इस बैटरी के across ऐसे जाऊं, तो I am moving from positive plate to negative plate. That is from higher potential to the lower potential. So here I will give negative sign. But if there is another person and that is traversing this cell in this direction, it means it is first encountering negative plate, then encountering positive plate. Negative plate means less potential, positive plate means more potential. So from low to high potential it is going. Now we will give here positives. Similarly, if across resistor you have to write, so you all must have studied in current, कि current flows from high potential to low potential. So if current is flowing in this direction, suppose, and I have to move along this resistor, along the direction of current. So if I'm moving along the direction of current, it means I'm moving from high potential to low potential because current flow from high to low, right? So if you're moving along the direction of current, you will give negative sign, and if you're moving opposite to the direction of current, you will give positive sign. ठीक है? Same thing will apply to capacitor. जैसे अगर एक capacitor है, यहाँ पे positive plate है, negative है. If you are going from positive to negative, it means you are going from high potential to low, you will give negative sign. Done? So these all are the rules you all must have studied. Again, it was just a recap of what you have studied already in your classes. So now if you're going to write KVL in this loop, इस लूप में हम लिखते हैं, मैं चलना कहाँ से शुरू कर रही हूँ? A से, and I am moving in this direction in clockwise direction. So I'm moving. First thing that I will encounter is resistance. Done. And I'm moving in the direction of current. So I will write, I have started moving from where? A से. तो मैं generally A से start कर रही हूँ, तो मैं A का potential लिखूंगी. BA मैंने लिख लिया, ठीक है? After that, I got one electrical appliance, that is resistor, and across it potential drop will be how much? Voltage पहले लिख लो, IR1 होगा, and we are moving in the direction of current, so minus sign दे दो. Now here it is a capacitor. Obviously current is flowing in this direction, or you can say that this capacitor plate is connected to the positive terminal of battery. So इसके पास positive charge होगा, इसके पास negative. Again, we are moving from positive to negative. We will give negative sign, and voltage on capacitor is written as Q by C. Again, here there is R2 in the direction of current we are moving, so minus IR2. And again, here I came. Here I encountered a cell. I am moving from negative terminal to positive, so I will write plus sign plus B. And again, I am reaching to where? A. So how I write is, मैंने A से start किया, जब A पर पहुंचने वाले हो, just give an equal sign and write below. So this is your KVL. Basically, VA will get cancelled. It won't come in the equation. So your equation is what? Minus IR1 minus Q by C minus IR2 plus B equal to 0. This is your KVL. Okay? So this is how you write KVL. You all must have done it. Now cells in series. Okay? How we combine cells in series? So ideal way of combining cells in series is, or most beneficial way of combining cells in series is what? It is this, like this. How? Negative terminal of one battery is connected to the positive terminal. Negative terminal of one is connected to positive terminal. You can see here. Done. Now how we add cells in series? So suppose कर लो first cell का internal resistance R1 है, second cell has internal resistance R2 and so on. Done. Now, if you will add it or subtract it, always remember that if cells are in series, it's not necessary that they will get added. They will get added only if orientation of their current is same. Like first battery, if you concentrate on first cell, that is E1, it will send current in which direction? In this direction, because current comes from the positive terminal. Similarly, E2 will send current in this direction. E3 is sending current in this direction. E4 in this direction. E5 in this direction. So all the batteries are sending current in the same direction. If it is so, then E equivalent we will write as, we will simply add them. Okay? We are going to add them like that. So E equivalent, if we are going to replace it by a single cell, then it will have EMF equal to E1 plus E2 plus E3 plus E4 plus E5, right? And this single cell will have some internal resistance. What will be its value? So simple है यार, पे all the cells have internal resistance. They are in series. So internal resistance will get added as we combine resistors in series. कुछ नहीं करना extra. So यहाँ पे क्या लिखोगे? R1 plus R2 plus R3 plus R4 plus R. So this is how we add cells in series. Done. Again, तुम लोग सोच रहे होगे, if current orientation is not same, then how we will deal with the cells in series? So let's see now here. यहाँ पे see, E1 will send current in this direction, E2 in this direction, है ना? But look at E3 carefully. This E3, its positive terminal is this. So it has tendency to send current towards right in this direction. E4 will send current in this direction, E5 in this direction, and E6 again in this direction. So add separately. Whatever is sending current towards right, add them together. So these are E3 plus E6. Now whatever is sending current towards left, add them. So यहाँ पे आप add कर लो E1 plus E2 plus what is E4 plus E5, right? So this is sending current towards right. This is sending current towards left. So total EMF, we will be subtracting these two. This will become your E equivalent. Again, R equivalent is not going to change. R equivalent here also it will be R1 plus R2 plus dot dot whatever number of cells are there. Okay. So that will remain the same. I hope it is clear. अगर किसी को problem हो तो बताना, ठीक है? Please do text me if you have any issue in the middle, or wherever you are feeling you are getting a stuck or you're not able to understand. You can easily text me or whatever you feel like do. But do ask. अब देखो यहाँ पे cells in parallel. How we combine cells in parallel? Positive is connected to the positive, negative is connected to the negative. First, we have to reduce these two to one. So this single EMF, single cell will have certain EMF, E equivalent, and also it will have certain internal resistance, that is R equivalent, and R equivalent will be same as we will join two resistors in parallel. So here 1 by R equivalent को आप क्या लिखने वाले हो? 1 by R1 plus 1 by R2. Simple है, ठीक है? How we will calculate E equivalent? So there is a formula. 1 by R equivalent तो लिख लिया. What is that E equivalent? E equivalent by R equivalent का formula क्या होता है? E equivalent by R equivalent is equal to E1 by R1 plus E2 by R2. So R equivalent you already have calculated from here. Now you can calculate E. So this is the formula. Okay. Now circuit shortcuts. I have just I'm just going to give you certain laws or tricks, I must say, or just I'm going to remind you if something like this comes in the circuit, how you will deal with those. Done. So यहाँ पे देखो एक register, 3 registers है, but the middle one register is connected. Middle one register is getting shunted. Shunt is what? If you are combining two ends of an electrical appliance with a conducting wire, okay? Wire that has no resistance basically. So here R2 is shunted. What will happen to it? Jaise if it is not shunted, if it is not, if this wire, resistance free wire is not here, then R1, R2, R3 are in series, we can see. So R equivalent will be how much? R1 plus R2 plus R3. if this wire is not there, if not shunted, right? If it is shunted, what is happening? Suppose kar lo ki this is connected to a battery. Okay. Now what is happening? Current is going like this. Current आया. अब यहाँ पे जैसे ही current पहुंचेगा, it has two ways to go. One is across R2, another is across it. It has zero resistance. तो रेजिस्टेंस को इस तरह से सोचो कि तुम मार्केट में गए हो, दो रास्ते हैं मार्केट तक पहुंचने का. वन वे इज वेरी मच क्राउडेड एंड अनदर वे इज बिल्कुल एम्प्टी है, इट्स जस्ट वेकेंट. सो विच वे यू विल गो? ऑब्वियसली द वन विच इज नॉट क्राउडेड, राइट? सो यहाँ पे भी क्या होगा, सारा का सारा करंट इधर से पास करेगा, इधर से कुछ भी करंट नहीं जाएगा. तो इट विल सीम लाइक कि R2 is not present in the circuit. So if you're going to redraw this circuit, it will look like R1 will be there, R3 will be there, and R2 will simply not exist because it is not participating in letting current flow. Done? So it's no longer there. If it is shunted, it means it is getting reduced to a wire having no resistance. That's it. ठीक है. अब यहाँ पे देखो, एक चीज जो हमें हमेशा ही निकालने को बोला जाता है कि सपोज कर लो यहाँ से करंट आई आया एंड यू आर आस्क्ड कि हाउ मच करंट विल फ्लो थ्रू R1 और R2. सो वी विल अप्लाई KVL, राइट? बट इन द एग्जाम you can't go through all these processes, all those equations and everything. So what is the easiest way? If you have to calculate current through R1, do one thing, write first I, whatever net current is coming at the junction, पहले आप उसको लिख लो. करंट किसके थ्रू निकालना है? R1 के थ्रू. So write R2 on the top and then at the bottom you write R1 plus R2. If you're going to apply KCL or KVL, you will get the same relation. ठीक है? So that is just to remind you of this thing, I am writing here. ठीक है? तो अब आप देखो I R2, current through R2 क्या हो जाएगा? I into, since we are calculating current through R2, on the top we will write R1 and on the bottom we have to write what? In the bottom we have to write sum of these two resistors. So this will give us current. Done? Easy and quick. Now how to deal with circuit having capacitor? So capacitor, if at t equal to 0, suppose कर लो यहाँ पे एक switch था and initially this circuit was not connected with the battery, disconnected. This capacitor has no charge, zero charge. The moment we will close the switch, what will happen? Current will start flowing. And initially, when there is no charge on the capacitor, it will behave like a conductor. So it will allow current to pass through it. So at t equal to 0, if you're going to draw the circuit will look something like this. Because capacitor is acting as a conductor. So at t equal to 0, if someone asks you to calculate current in this circuit, so you will say कि current is E by R. Done? ये भी याद रखो. Later we will learn in RC circuit. Okay, I will teach you RC circuit. No worries. But for now we need to just keep these things in our head. Now what will happen if we talk about current in steady state? Yes, Satyendra, बोलो. JNV या बतमल, हाँ बोलो. You have any doubt? Any doubt from the previous stage? Okay, let me know if you have doubt. Okay, because you have texted me. So I just want to know. Now what will happen? You see here again, if I'm talking not about time t equal to 0, if I'm talking about long time, and that is called basically a steady state. If in the question it is given that steady state has reached, or if in the question it is written that after long time, so after long time this capacitor will behave as an insulator. ठीक है? ये किसकी तरह behave करेगा? Insulator की तरह. So wherever in capacitor is there, after long time that branch will act like a open circuit. Done? So here if I talk about at t equal to infinity, that is after long time, then this circuit, this branch will get open. So it will not receive any current because it has become an insulator. Done? So this thing you need to remember. remember. Okay, now circuit shortcuts में एक और है horizontal plane of symmetry and vertical plane of symmetry. तो देखो ये बहुत ही simple है. Suppose कर लो कि you have to calculate R equivalent resistance between 2 points A and B. So there are network of resistor connected like this, or any complex structure it can be. So what is horizontal plane first? So just combine this A and B. Done. So plane passing through this line, horizontal plane passing through this line is horizontal plane. And if around this plane the circuit is symmetrical, then we will say this is following horizontal plane of symmetry. जैसे आप यहाँ पे इस plane को अगर mirror की तरह देख लो, तो you can see that top part is the mirror image of bottom part if both has the same value of resistance. Done. So in this case, we will say that it has horizontal plane of symmetry. Done. We'll learn it more. जैसे यहाँ पे देख लो, अगर we have to calculate R equivalent across A and B. So combine A and B. So this line is your what? Plane, horizontal plane passing through AB is your horizontal plane of symmetry. That's it. अब समझ गए? So this is horizontal plane of symmetry. Now, sorry, this is horizontal plane. Symmetry है या नहीं ये check करना होगा. So just treat it like a mirror. Treat it like a mirror and see if top part is the mirror image of bottom part. If it is, then it is following horizontal plane of symmetry. So यहाँ पे आप देख लो top part, bottom part का mirror image है. So this is the case of a horizontal plane of symmetry. अब देखो क्या फायदा है जानने का. So points that are mirror image about the HPS have the same potential. जैसे this is the horizontal plane. So if it is symmetrical around this plane, it is. So whatever point is the mirror image of another point, they will have same potential. Here you see C is the mirror image of D. है ना? So potential of C and potential of D will be equal. ठीक है? First thing, only thing that you need to remember in horizontal plane of symmetry. अब देखो vertical plane of symmetry is very much helpful in solving circuits. अब यहाँ पे आप देख लो, this line is horizontal plane. So draw a line perpendicular to this AB and plane passing through this. Perpendicular कैसे बनाना है? Such that it is bisecting AB. It is bisecting AB, right? AB is what? AB is the point along which you are calculating R equivalent. तो ये line को हम क्या बुलाएंगे? Vertical plane. And if the circuit is symmetrical around this vertical plane, we will say that it is following vertical plane of symmetry. अब देखो how it is helpful. Let's look at now. अब यहाँ पे देखो vertical plane of symmetry अगर मैं बनाऊं, around AB we have to calculate R equivalent. So vertical plane will be this, and around this line you can see clearly the circuit is symmetrical. Done. So this is what? Symmetrical. So branches that are mirror image about VPS have the same potential. अब देखो यहाँ पे this is mirror image of this one, so they will have same potential. Done. Similarly यहाँ पे देख लो, this is mirror image of this, so they will have same potential. This is mirror image of this, they will have same potential. Over. Points on VPS have same potential. So vertical plane of symmetry वाला line ये था. इस point पे जो भी line होगा ना, इस line पे जो भी point होगा, they will have same potential. So here, this is the point, this is the point, this is the point, this is the point. If they have same potential, it means no current will flow in this resistor, no current will flow in this resistor. So from this geometry, we can simply remove these two resistors, and then circuit will become more easier. है ना? तो वही करना है हमें. Knots lying on VPS can be opened. इसका क्या मतलब है? जैसे वर्टिकल प्लेन ऑफ सिमेट्री यहाँ पे कौन सा लाइन है? ये लाइन. इस लाइन पे एक नॉट है. यहाँ पे देखो बहुत सारे रजिस्टर्स आकर मीट कर रहे हैं. सो दिस इज अ नॉट. Done. So if there is a knot lying on the VPS, vertical plane of symmetry, we can open it. कैसे ओपन कर सकते हैं? यहाँ पे देखो, इस नॉट को मैंने ओपन कर दी. सो इसको ओपन कर. Now it is very easy to solve this circuit, है ना? This is and this is, they are in series. After opening the knot, ये रजिस्टर और ये रजिस्टर भी किसमें हो गया? ये और ये रजिस्टर किसमें हो गया? सीरीज में हो गया. So now it is very easy to solve this question. right? So it is very important to know such things. This is all. Okay. So now we have a question. Anyone has any doubt? Again, question is very easy. So take 1 minute and do it. Everyone be ready with your pen and copies. Don't feel lazy or don't feel anything. Like कि चलो कॉपी बंद करके चलते, ऐसी वाली फीलिंग नहीं आनी चाहिए, है ना? You are given 1 minute. Do it now, fast. Potential difference is given, है ना? When the circuit is open and when the circuit is closed, है ना? So in for cell you must have studied this thing because this is very much basic. Let me know now. Come on, guys. जल्दी से बताओ क्या आ रहा है. No one got it. Yes, let me know what will be the answer. JNV Gandhinagar, yes. JNV Dahod, yes. Very good. Come on, yaar, this is the most simplest question that you can get from current electricity. Please do it. तुम लोग revise करके नहीं आते. You don't do homework. You don't do any back work. You do nothing in the back hand, na? JNV Gandhinagar, yes. तुम लोग का क्लास खत्म होता है ना, आफ्टर दैट यू फील लाइक यू आर डन. यू नीड टू स्टडी एट योर होम ऑल्सो, इन योर रूम ऑल्सो. इसलिए मैं लेकर आती हूँ 10 क्वेश्चन ही नहीं हो पाता. आधे टाइम तो मुझे लेक्चर देना पड़ता है. सिंपल थिंग यू आर नॉट डूइंग, सेम लेक्चर. यार यू शुड बी सीरियस अबाउट योर करियर एंड एवरीथिंग ना. हु विल डू दैट? चिकबलपुरा, यस, करेक्ट, वेरी गुड. कम ऑन यार. One thing I'm telling you, if you can't help yourself now, nobody is going there to help you. Just get it in your head. Aswini, yes. ये बात समझ लो, जितनी जल्दी समझोगे उतना अच्छा है. Now, what is the question? जैसे question is simple. If you have a cell like this is the internal resistance, this is the EMF. There is difference between EMF and potential difference, है ना? So EMF of cell is what? If okay, JNB Nandev, if there is no current flowing, suppose कर लो यहाँ पे current flow नहीं कर रहा, done. So circuit is open. So if you have to calculate potential difference between the cell, what it will be? If you're going to move like this, you will encounter positive plate minus E, no current flowing. या फिर इधर से चलो, जैसे भी चलो, मॉड्यूलस इफ यू आर गोइंग टू टेक, यू विल गेट ओनली मॉड, ओनली ई ना. So potential difference between the cell when there is no current will be equal to E, done. And if current is flowing, क्योंकि current का डायरेक्शन मैंने ऑपोजिट ले लिया था, इसलिए यहाँ पे नेगेटिव वैल्यू आया, डन. एंड इफ करंट इज फ्लोइंग इन द सेल, चलो अब सिंपल सा ऐसी बात है, ये E है, एंड इफ it is connected to some external resistance R. Now what will happen? Current will flow. Done. And if current is flowing, current का value पहले लिख लो कितना होगा? E by R plus R. So current is flowing. Now if we have to potential difference between cell, what it will be? Cell का मतलब this two lines plus this internal resistance. So potential difference between cell कहने का मतलब क्या होता है? Potential difference between these two points. Then what it will be? What it will be again? Right here, आप इसको A मान लो, point को इसको B मान लो. So write KVL while moving from A to B. तो मैं A से चलना start करती हूँ. VA, I'm moving in this direction, suppose. So first I will encounter battery minus 3, and I'm moving opposite to the direction of current. So I will write here IR equal to B. Now VA minus VB will be equal to how much? E minus IR. So this will be the potential difference when current is flowing. If there is no current, I0 करोगे तो VA minus VB क्या हो जाएगा? E हो जाएगा. Done. So simply now calculate the resistance and put the value. Sorry, calculate the current and put the value. So for cell, potential difference is 2.2 when circuit is open. So if circuit is open and potential difference is 2.2, it means value of E is how much? 2.2. Now it reduces to 1.8 when cell is connected to 5 ohm resistor. Done. So VA minus VB is how much? It is 1.8. E का वैल्यू हमें पता चल गया 2.2 माइनस I का वैल्यू आप लिख लो. I क्या होगा? 2.2 divided by 5 plus R into R. This will be the equation, and now you need to solve this equation, and after solving you will be getting A as the option. So this is a very simple question. You need to have it in your head. Difference like potential difference across cell when no current is flowing, when current is flowing. When no current, just have it in your head. It is equal to E, EMF. And if there is current, potential difference between cell is equal to how much? E minus IR. Done. Now this is a very easy question, very easy question. I'm giving you 1 minute again, and this time I need more answers. जल्दी से सब लोग बताना मुझे क्या क्या आ रहा है. लेजी मत फील करो यार, प्लीज डू. पता है तुम्हें ना बस 6 महीना सीरियस रहना है. इफ यू आर सीरियस फॉर 6 months ना, you're going to get some good colleges. So be serious for another 6 or 7 months. It's very much required. In this long life of 16 years or 15 or 17 years, whatever you are, can't you give your 6 month for your progress? You should, है ना? चलो, this is the good deal. Gandhi Nagar, yes, very good. Come on, everyone. Come on. Only thing is you have to write the KVL, nothing else. KVL कैसे लिखना है? VA minus VB you have to calculate. Start moving from A, and if you have to end at B, so start moving from A, write whatever thing is there, give equal to sign, and end at B. है ना? JNV Nanded. It seems like I don't remember the answer, but it seems like wrong. Let me check here only. Yes, you need to look at that. JNV Dahood. Yes, correct. No, wrong. Why everyone is getting this? Come on, do it here. I should not give much time to this question at least. JNV Dahood. Yes, now you're correct. Yes, correct. Nobody is replying on YouTube. क्या हो गया? आंसर कर लो यार. JNV पूरी पूरी नहीं, पुणे, सॉरी, चिकबलपुर. यस, करेक्ट. करना ही नहीं था कुछ. I should not give much time. Just start moving from A. Current is flowing in this direction. It is given. It is equal to 2 ampere. JNV Simoka. Yes. So it is equal to 2 ampere. Done. You have to calculate VA minus VB. Start moving from A. So you write VA. Now, if you're moving in this direction, first thing you encounter is 2 ohm resistor. So right here, potential drop across the resistor is equal to IR. We are moving in the direction of current. So minus sign 2, I value 2, R value 2. Now battery, we are moving from positive to negative. Again minus sign 3. Again, we are moving in the direction of current across resistor. So again minus sign I2, resistor 1 equal to, we have to end at B, right? This is not a closed loop. So if this is not a closed loop, we can't write this equal to VA, right? We are ending at B. So equal to sign देके आप VB लिख लो, ठीक है? So this is how we write KVL in a straight line, in not in a closed loop. So VA minus VB will be equal to how much? 4 plus 3 plus 2. So this is equal to how much? Now you can know what is the answer. So the answer will be that. Kolhapur, yes. Again, I won't give you much time. I'm giving you 1.5 minutes. ठीक है? तो ध्यान से क्वेश्चन को देखो सत्येंद्र, यस करेक्ट। चलो अब इस क्वेश्चन को ध्यान से देखो तुम लोग और सही से करने की कोशिश करो। अगेन क्वेश्चन इज नॉट डिफिकल्ट, यू जस्ट नीड टू ऑब्जर्व द क्वेश्चन। Zenbi Gandhi Nagar. It seems incorrect. Okay. One answer I got on YouTube. It seems correct. If you have given this answer for this question on the screen now. Neha, it's not correct actually. Look at it more carefully. You have to calculate potential difference between A and B. है ना? Gandhi Nagar seems like correct. Seems like. I will let you see what the question is. ध्यान से क्वेश्चन को देखो, यहाँ पे 5 ohm रजिस्टर है और यहाँ पे एक बड़ा सा मिडिल में कुछ चीज है ना? A network of resistors and capacitors it is. JNB Stimoga may be correct. Let's see. So एक network of resistor and battery है, cell है, and again there is a resistor. Done. So if you look carefully, these 3 are cells connected in parallel. Can you see it now? Batteries are like this, negative, 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 and they are connected like this, na? है ना? So they are in parallel, right? So actually, what is Dahod? Yes, maybe. So what you can see now is basically 3 cells are there and they are connected in parallel. So if we are going to reduce this network into a single cell with certain resistor, we can reduce it, right? Because we know the formula. After that, what this circuit will look like. So this is the point A, this is the point A, and here there is a resistor of 5 ohm, and then there will be a single cell having some internal resistance. This is C, and this is your what? D, and again between C and B there is a resistor that is 10. Then so my circuit will look like this. Now we have to calculate voltage potential difference between A and B. तो आप क्या करोगे? Again इसका E equivalent तुम लोग formula से निकाल सकते हैं, है ना? That we can do. Now if we have to calculate VA minus VB, what we will do? We will write KVL along the straight line. So A से start करो, move करना VA. Since there is no current, voltage drop across resistor will be 0. So VA plus 0. Again, this is the battery. So we will write here minus E equivalent. Again, resistors are there, but since there is no current, no potential drop, equal to VB. So VA minus VB will be equal to how much? E equivalent. So simply you have to calculate the E equivalent of this network. Now, how you will easily calculate the E equivalent of this network? कैसे निकालोगे बताओ? You all have the formula now. So 1 by R equivalent सबसे पहले लिख लो. How much will be the value of R equivalent? So 1 ohm, 1 ohm, 1 ohm in parallel. So R equivalent will become what? 1 by 3. It will become 1 by 3, right? So R equivalent तो मुझे मिल गया. Now the formula is what? E equivalent by R equivalent is equal to E1 by R1. So 1 by 1 plus 2 by 1 plus 3 by 1. So this is giving us 6. Now 6 into R equivalent को आप इधर ले जाओगे तो E equivalent मिल जाएगा ना. So 6 into 1 by 3. So the answer will be 2 volt. Answer will be 2 volt. Everyone is getting A. Some got D, I guess. Some and many of you got C. So yes, Narayan Sneha got it. Very good. So the correct answer will be D. Now do this question again. This is very easy. Again, I'm giving you 1.5 minutes. देखो कितने easy questions आते हैं. Okay. JNB, Gandhinagar, Pune. Okay, very good. Others, please come on. JNB, Bhavnagar, yes. JNB, Dahod, Gandhinagar, yes. Come on, guys. JNB, Simoga, Jamnagar, Kolhapur, Guntur. कहाँ हो सभी? सो रहे हो क्या? राजकोट, ओस्मानाबाद, सतारा. सतारा इज अ नाइस प्लेस. हाँ. जेनवी, वाईजैग, मानसी, तापी. क्या हो गया सबको? Why so much silent? I need more answers. Come on, yaar. Sneha, what will be the answer? Narayan. Chalo, I've given you all enough time. Question is very easy. Again, you just need to apply the KCL. See here, current is coming from this direction. Current is coming from this direction and going out in this direction at junction C. So let this current be I1. This is written also. This current is I1. This current is I2. And this current is how much? It is something I. Hana? We have to calculate the value of current I, right? So if you write here, I1 plus I2 will be equal to I. Hana? Total amount of current coming to the junction is I1 plus I2. Going out of the junction is I. So this is this. Now I1 को आप लिख लो. So let's suppose कि potential at C is VC. So if current is flowing in this direction, means potential of A is greater than that of C. Potential of A is given, that is 20. So current will be potential difference divided by resistance, that is 2. So I1, I2 will be what? Again, current is flowing in this direction. It means VB is greater than VC. So VB is 10. VC को VC लिख लो divided by 4. And this will be equal to how much? I. So this current is flowing through 2 ohm resistor. Again, this is grounded. So its potential is 0. Current is flowing in this direction. VC is greater than 0. So we will write VC by 2. है ना? Something like that. एक काम करो, make denominator equal. Okay. Krishna, yes. No, not correct actually. तो यहाँ पे आप देखो make denominator equal. तो 2 into 2 मैंने किया, यहाँ भी 2 लिख दिया, यहाँ भी 2 से multiply किया. Here I'm writing 2. 4, 4, 4 will get cancelled. Now you can write here 40 minus 2 VC plus 10 minus VC equal to 2 VC. If you're going to bring VC on the left hand side, you will write here 50 equal to 5 VC. है ना? So VC equal to how much? 10. Now I value will be how much? 10 by 2. So that is equal to 5 ampere. So the correct answer is D. Okay, done. Now solve this question. Again, you just need to write the KVL. Do it. I'm giving you 1.5 minutes again. Do it. Just KVL you have to write. You can do it within 30 seconds. Do it now. रुशिका, रसिका, सत्येंद्र, तेजस्विनी, वैभवी, क्या हुआ? रिप्लाई दो सारे लोग यार. गांधीनगर. ओके ओके. हाय कशिश. she's still connecting to audio. Okay. Hi Kashish. Hi. Okay. Gandhinagar. Dahod. Okay. Very good. Come on, everyone. Zembi, Gandhinagar. Yeah, correct. Shimoga, done. Others, please take the effort of writing your answer in the chat box, please. JB, Dahod. Thank you. Most welcome. But thank you for what? जो नहीं कर रहा मैं बता रही हूँ, it's not good. Just KVL you have to write here. Still so less number of answers I'm getting. This is something out of expectation, like something beyond. I can't imagine it happening. What you have to do here in the question? Aswini. Okay, done. What you have to do here? You have to calculate potential of the point B, and potential of the point A is given. That is 0. So simple thing you have to do. You have to write KVL from A to B. Done. Now, along which path, Dhanasri, yes, along which path you will be writing the KVL, it will, you should wisely choose it. You should choose the way along which all the variables are known, right? So just see along which way all the variables are known. Okay, Vaibhavi, Tejashwini, everyone. Okay, ठीक है, done है, thank you. So which way you can go? Just see here. If you are coming in this way from A to C and from C to D and then to B, then from C to D current value is not known. Is it known? But it can be known by using KCL. तो यहाँ पे इस C junction को आप ध्यान से देखो. 1 ampere current is coming. 2 ampere is current is going out. It means 2 ampere of current must be coming to this junction. So from here, 1 ampere current will come like this, and then here 2 ampere current will go out, right? तो इस आर्म में हमें करंट मिल गया 1 ampere. Now let's go or let's write KVL from A, C, D, P, right? तो चलो लिखते हैं VA. We are moving like this. So from negative to positive we are going. We will write plus 1 volt. Again in the direction opposite to current we are moving. So we will give plus sign 2 into 1. Again along the battery we are going from negative to positive, so we will write how much? -2, and this will be equal to VB. -2 plus 2 will get cancelled, and VA is equal to 0, so VB will be equal to how much? +1. That's the answer, right? Yes, Rushika. Class 11th. Okay, no, not correct answer. That is, answer will be +1 volt. So it's very easy. Chalo, do this question. Do this fast. Don't get afraid of this question by just looking at it. All this graph and long words. This is very easy. I'm telling you, you can do it within 30 seconds after reading the question. So do it now. And let me know the answer that you're getting. Yes. Yes, Gandhinagar, very good. Very good, very good. Come on, everyone else, do it fast. Okay, I got so many. JNV, Nanded, 12th class, Gandhinagar, Mansi, Purnima, Rishika. Okay, done. Everyone, great, 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 great. JNV, Pune, yes, Gandhinagar. अरे किसका गलत है यार ये? JNV, Gandhinagar. Look at it carefully once more now. स्नेहा, स्नेहा एक बार और देखो सही से. JNV, Anand, Simuga, correct. Dahod, correct. Pune. Chalo. Question is very easy now. What is there in the question? There is a battery consists of a variable number n of identical cells which are connected in series. So they are connected in series. And each cell has an internal resistance of some R. Done. There are n number of cells. So if we can replace it by single cell, it will look like this. Ne. And its internal resistance will be equal to NR because they are in series. Now it is short circuited. It means both of its ends are connected through a conducting wire. Now what will happen? Since the circuit is closed, current will flow. How much current will flow? Current का value आप क्या लिखोगे? Total voltage, that is NE by total resistance, that is NR. So current is what? E by R. So current is independent of number of cells we are connecting. Sorry, NR small r hai. Done. So I will not depend on small n. It will be constant. It is E by R. So the correct graph will be first. Okay. Chalo. Do this question again. You have 3 minutes of your time. So I'm giving you 2 minutes to solve it. Again, you don't need this much, but still I'm giving. Do it fast. I'm giving you a hint. This is a single loop circuit. Single loop. एक ही loop है ना? So this is single loop circuit. In single loop circuit, whatever registers numbers are there, they all will be in series. Whatever number of cells are there, they all will be in series. But ध्यान से देखना कि series में वो add होंगे या subtract. And that you will check by writing their current orientation. So do it now first. ओके गांधीनगर कैसे आ रहा है ये ऑप्शन इट शुड नॉट कम आई टोल्ड यू दिस इज अ सिंगल लूप सर्किट ऑल द resistors are in series क्योंकि whatever current is flowing same current will go through all the resistors now they are in series also here there are two cells they are in series now try to see if they will get subtracted or added ध्यान से देखो रुसिका yes Neha yes very good गांधीनगर फिर से भटक गए रास्ते not that option you will get again consider it Kashish yes this is a single loop circuit Janvi Rajkot Mansi Rashika yes single loop circuit है ना all registers are in series R equivalent क्या दिख रहा है यहाँ पे R equivalent देखो 9 plus 2 plus 1 that is your 12 ohm what will be E equivalent two cells are in series 8 volt will send current in this direction 4 volt will send current in this direction so we will subtract it how much you are going to write 4 so current value will be how much 1 by 3 and only one option has current as 1 by 3 so this will be correct Again, second thing you need to calculate potential difference between P and Q. You just need to write KVL, है ना? क्या लिखना होगा? KVL. Weta, yes, no. Now you must be clear, I guess. Okay. Okay. Thank you, everyone. Vaibhavi, Janvi, Shimuga, Smini, Tejashwini, Dhanashri, Janvi, Kolab. Okay, done. So we couldn't solve much question again. We will be solving more number of questions tomorrow, and in the tomorrow class I won't be discussing any topic or anything. Purely I will start from the question. Okay, and from next weekend classes, जो भी अगले week से अगले के अगले week से होगा, again I will be simply starting with the question. क्यों? क्योंकि weekdays classes are starting, so there I will teach only, na. So in these classes I will plainly go with the question. Done. So there are more questions that I needed to discuss, but I couldn't. Anyway, so I have attached some 6 or 7 questions as homework. I will love you to go through those questions. Please go through that. You can access notes where in the description of YouTube channel. जैसे YouTube channel पे जाओ, live one है ना, सबको पता होगा, and there you will get these notes in this particular video, जिसका प्लेलिस्ट का नाम क्या है? Enable class 12th Enable 2023. Done. So go there and please go through notes for solving question. Please do solve question. Homework करना है. तुम लोग homework करते नहीं हो. If you're not doing the homework, you won't improve. It's very much important. ठीक है? तो चलो कल फिर से मिलते हैं at sharp 11 o'clock. We will be solving lots of questions tomorrow. Okay. Bye everyone. Take care and do read. Do read a lot. Okay. Bye. Start. अच्छा. 12 can't understand. Okay. Others can leave क्योंकि तुम लोगों का क्लास होगा, किसी को समझ में नहीं आया है तो मैं वो एक्सप्लेन कर लेती हूँ. ठीक है, तुम लोग और लीव कर सकते हैं. ठीक है, क्योंकि यू नीड टू ज्वाइन अनदर क्लास ना. तो एक काम करो, जिसको समझ में नहीं आया स्टे कर जाओ. मैं बताती हूँ यहाँ पे करना क्या था. देखो ये जो क्वेश्चन है, इन दिस क्वेश्चन यू कैन सी सिंगल लूप, है ना. सो जैसे देयर आर 2 बैटरीज and these 2 batteries have their internal resistances. One has internal resistance as 2 ohm, another has internal resistance as 1 ohm. Okay. Again, you have to calculate current in the circuit. If you can see here carefully, all the resistors are in series. Why in series? Because if current is flowing in this circuit, same current will go through it. Loop है ना, single loop है. Single loop में मैंने तुम्हें ट्रिक बताया. Every element is in series. ठीक है, तो R इक्विवेलेंट तो सिंपली ऐड करोगे सीरीज में. सो 9 + 2 + 1 12. नाउ व्हाट अबाउट द बैटरी? डन. सो हियर 8 वोल्ट बैटरी इज हियर. its positive terminal is this, negative is this. So positive will send current in this direction, है ना, and negative will send current 4 volt will send current in this direction. So these 2 batteries are sending current in different directions. But in the circuit, current will exist only in one direction, right? So which direction will dominate? The one which has high potential value. That is direction of 8 volt. So net current will go in this direction. Again, what will be the net voltage? So 8 minus 4, not 4 minus 8. Obviously 4 is of a less value, 8 is of high value. So 8 minus 4 we will do. So circuit will get reduced like कि ऐसा हो जाएगा. इसके पास voltage होगा 4 volt and it will have resistance value of 12 ohm and circuit will look like this. So now current you can calculate. ठीक है? I hope it is clear. Is it clear? The one who asked, I fear if he or she has left, I don't know. नहीं, they're here. Clear है? Please let me know यार. Okay, thank you so much. Thank you. Sorry for taking more time. Bye, Tata, take care. And thank you for the love, everyone. Thank you so much. Bye. Thank you.